Hello, scholars. We're going to continue in chapter 4, and these are notes I would like you to write down into your notebook. So, whatever the next page is for you, please turn there. I want you to number the page, put at the top of it, end behavior notes, and date it. Today should be the 4th. End behavior describes what we're going to call the far left and the far right portions of the graph. So we're going to look at the powers of the functions, and we're going to see where the ends end up. This is the far right. This is the far left. We're going to use something called the leading coefficient test, and it's using the leading sign and the degree of the polynomial. We can determine the end behaviors. So I want you to sketch this. Do just a little XY axis. And we're going to do a function that looks like this. Put arrows on the end and label it f of x. So what we're doing is we're looking at where does this arrow go to? As x approaches infinity, meaning as x goes to the far right, where is that y value going on that green arrow? You can all see that this particular one is going straight up. And so we would say that as x approaches infinity, that's what that arrow means. As x goes this way, y, or f of x, goes this way. And it keeps on going until infinity. If we look at the left side, we say as x approaches negative infinity, then this end of the green line, the polynomial, approaches negative infinity because it's going to keep going down and down and down. So infinity is all the way out here, negative infinity is all the way out here, positive infinity for the y is here, and negative is here. So I'm going to go through, there's only 4 possibilities, and I'm going to go through each one. So if I have, well, do these sketches on your paper, do a box of 4 of them. Give you another second to do that. And of course, you can always pause and take your time depending on how fast this is going. But we're going to start with an even degree. And both of these here, we're going to do even. That means we're also going to do odds down here. That's all you can have, either even or odd. So if I have a leading coefficient that is positive, that's one situation. And if I have a negative, that's another situation. Okay. Same thing for the odds. We can either have a positive coefficient or a negative. So as you're doing this, leave some space for some sketches. And I'm going to put up some sketches here about what it might look like. So a positive even function looks like a parabola. The highest degree is 2, and that's even. So any type of polynomial with an even degree and a positive coefficient is going to look like this. If it's negative, it's going to look, in general, like this. So we know that either the ends are going up or the ends are going down. That's what you can tell from this picture, those two situations. Now, since you're sketching, even both up, both down. Odd, if it's positive, this side goes up, but this side goes down. If it's negative, switch it. This side goes up, this side goes down. And that's any odd function. So it could be x to the 1, x to the 3, x to the 15. In general, this is what the ends are going to look like. So that's why we call it end behavior. Now we're going to write specifically some new notation. And so for each one of these, you're going to write as x approaches infinity, you look at this, as x is going to the right, where is the y going? It's going up. So you're going to say f of x, or the y, goes to infinity. That's the right side. Then you'll do the left. As x approaches negative infinity, so it's going to the left. Where is the orange line going? It's also going to positive infinity. So as x goes this way, y goes that way. As x goes this way, y goes that way. That's the end behavior for an even positive polynomial. You may be able to guess about the negative. Same end behavior description. As x goes to infinity, the difference is f of x is now going down. So it's going to negative infinity. And as x goes to negative infinity, so it goes to the left, f of x is going also to negative infinity. So even whether it's positive or negative, they both go the same direction, both up, both down. Then, of course, we will continue for odd. Same notation, different locations. So as x goes to infinity, that's on the right. The y's, or f of x, is going up to positive infinity. As x goes to negative infinity, or to the left, the y's are going down. So we say negative infinity. And of course, this will be opposite. As x approaches infinity, so x goes to the right, f of x goes down. As x goes to the left, f of x goes up. Okay, so at this point, your guest teacher, or if you're just watching, should pause this, let you catch up, okay? I'm going to be showing some examples but these are the notes I expect to see in your notebook. Here are some more notes. Since we're moving on, I actually have a little foldable thing that I'm going to have you do when we get back. But I wanted to simply show some examples of what these look like and then complete this a little bit more. So let's start with a positive, even-powered function. My example is y equals x squared. Here, a equals 1. The way it looks, as we know, is 0, 0, 1, 1, 2, 4, and it can be a sketch like that. So the end behavior that we would write is as x goes to the left, f of x goes up. As x goes to the left, f of x also goes up. So they're both going up on a positive even. If I have a negative even, my example is y equals negative x squared. Here, a is negative 1. Well, it's the same graph, just upside down. 1, 1, 2, 4. And it's going down this way. And behavior, just the ends, as x goes to the right, f of x goes down. So negative infinity. As x goes to the left, f of x goes down, down, down. So again, positive even, both up. Negative even, both down. So then we'll look at a couple other examples. Here, I want positive odd, y equals x cubed. Again, we have a equals 1 with our standard. And it looks like this. Half, 1, 2, 3, 4, is a parabola. But the other half goes the opposite direction. 2, 1, 2. So it looks like that. So it's an odd degree positive coefficient. As x goes to the left, right, then f of x goes up. As x goes to the left, f of x goes down. So it's negative infinity. And then our fourth example, a negative odd is y equals negative x cubed, where a is negative 1. And now it's the same on this side, on the negative side like that. But then 2, 1, 2, 3. So it's half the parabola this way and half the parabola that way. Review as x goes to the right. So on this side, y is going to negative infinity. And as x goes to the left, y is going to positive infinity because it's going up. We'll do a couple more examples when I get back, but that is the gist of end behavior.